We're going to solve multi-step equations with the applications of the distributive property. This is part one. We're going to go a little slower. You're going to have equations like this one, and then they're going to progressively get harder. In part two, we're going to do two steps at the same time. In part one, the video we're doing now, that you're viewing now, we're going to do one step pretty much at the same time. We're going to go a little slower here. So we have this first one, and you should already know about the distributive property. Basically, we're going to distribute by multiplying negative 5 times 1 and negative 5 times 5b. So negative 5 times 1, and if I bear with just kind of multiply in your head here. So this will be negative 5. And when you multiply negative 5 times 5b, you get negative 25b. And that equals 145. Now at this stage, once the parentheses are gone, we're going to do the PEMDAS backwards. And we already discussed this in a previous video. So we ask ourselves, is there anything we could add or subtract to both sides to help isolate the b? And we can. We can add the 5. So we add 5 to both sides. And then we get negative, this zeroes out, that's the zero property, equals 150. Is there anything we can multiply or divide by? So we already did that. Yes, we can divide both sides by negative 25 to isolate the b. And when we do that, this becomes 1. Negative 25 divided by negative 25 is 1, and we get b equals negative 6. So our solution set is negative 6. All right, next one. Again, I have a quantity here of 1 minus 8n. I don't want to start doing the PEMDAS backwards trick until I distribute and collect like terms. So when we distribute here, we get 4 times 1 is 4. 4 times negative 8 is negative 32n. I'm going to add the 3 here. Just carry him down. And I'm going to combine like terms. So basically, I'm going to combine those two, and I get 7 minus 32n equals 263. Now that I've gotten rid of the parentheses and collected like terms, I can do PEMDAS backwards and ask, is there anything we could add or subtract to both sides? Yes, we can subtract the 7 from both sides. And a lot of times I put the line through the 7 because sometimes they look like 1s. You don't have to, but I try to sometimes. So this is going to give us 256. And divide both sides by negative 32. That's that part. And so you can either use a calculator, and the answer is going to be negative 8. So our solution set is negative 8. Okay, the next one, we have something like this, and I find the students have a hard time with this. When you see something like this, a lot of times the students try to add these two if they can. Here you can't because they're unlike terms. But a good way to make this less confusing is to put this guy, let me do a different color, this guy here in the back. So I'm going to copy him down in front here. So we get 1 plus 2n. And then say minus 3n. Remember, minus and negative both mean take away. So they can be used interchangeably. Now I have it where I can distribute here. I get negative 6 minus 12n, and then carry down the 3n equals negative 96. Combine like terms. These are my like terms. So we had negative 6 minus 15n equals negative 96. Now, since I've I've got rid of the parentheses, and I collect it like terms. I'm doing PEMDAS backwards, and I ask, is there anything I can add or subtract to both sides? Yes, I can. I can add 6 to both sides. Opposite of negative is positive. So when you add negative 6, or add 6 to both sides, we're going to get negative 15n equals negative 90. So n is going to equal, how many 15s go into 90? So that's going to be 6. But basically, you're dividing, both sides by negative 15. I skipped a step, sorry. Divide both sides by negative 15. And that gives you 6. That's just, so n is 6. Okay, here's one where the x that we're trying to solve for is on the right-hand side, and that's no big deal. It's just reading it different. I'm going to first get rid of the parentheses by doing the distributive, performing the distributive property. Get 12x plus 8, carry down my 8, and this makes it nice here because 8 minus 8 is 0, so that goes away and cancel. Then all we have to do is divide both sides by 12, and negative divided by a positive is going to be a negative, and when you divide, you're going to get negative 7 equals x. So our solution set is negative 7. And the same thing here. The first thing I'm going to do is get rid of the parentheses by distributing. Get negative 56x minus 49. I'm going to, sorry about that, I'm going to do PEMDAS backwards. And I'm going to go ahead and add 14 to both sides. This is the add and subtract part. Oh my gosh, what does that equal? You add 14 to that, it's negative. You add, the way I do it is, if I'm doing this in my head, I would add 15 to that. That would give me 90. So since it's 14, it's going to be 89, I believe. Let me see if I copied this down right. So negative 56. Oh, this is what I did wrong. Did y'all see it? You should have told me. All right. So basically, this is going to be right here is where I messed up. I added instead of multiplied. Now I'm going to add 49 to both sides. And when you get that, you're going to get negative 56 equals negative 56x. Then we're going to divide. We're going to divide both sides by negative 56. That gives you 1, and this gives you 1. So my solution set is 1. Okay, the next one, it's basically the same thing, except it has 2 terms on the left, the 6 plus v. So I'm going to distribute, and we get negative 49v plus 56, and this equals 6 plus v. Now, is there anything I could add or subtract to both sides? We're doing PEMDAS backwards. Yes, I can. I need to isolate v. So I can either put v on the right side or the left. Since I'm going to put my v on the right side, what I'm going to do is subtract 6 from both sides here. So I get v equals negative 49v. I subtract 6, and that gives you 50. Oh, not equals 50, but plus 50. 56 minus 6 is 50. And now I'm going to add 49v. This is why it's called multi-step. You have to move over twice. This will cancel. This is 1V. It's like saying one violin, or a violin plus 49 violins is 50 violins. So you get 50 violins equals 50. Divide both sides by 50. And again, it's like the previous problems. We get V equals 1. So my solution set is 1. Okay, the next one, I'm going to distribute. 4m minus 32 equals negative 38 plus 3m. I'm going to do PEMDAS backwards. First thing I'm going to do is go ahead and leave my m on the left side. So I'm going to add 32 to both sides. And remember, when you only can add to like terms, you get 4m equals negative 6 plus 3m. And then I'm going to subtract 3m from both sides here. And you get m equals negative 6. So my solution set is negative 6. The next one looks really bad. This part right in here is where usually the mistakes are made when you're taking a test. So what I like to do is I'm going to go ahead and just rewrite this guy. And I'm going to put him first and write him down. And then put him back here. It just looks better. I'm going to go ahead and distribute. So I'm going to copy him down and distribute here. So I get 42a plus 21 minus 4. And copy it down again. Whoops. 42a minus 17, because I'm combining those two. I'm going to keep my a this time on the left. So I'm going to add 17. I'm doing PEMDAS backwards here. Add 17 first. You put the little line through if you want. And that zeroes that out and leaves 42a on the left-hand side. And this is going to equal 17 and 10. Each one said it was 12. So this is negative 12 minus 4a. Again, I'm not using a calculator, so hope I do this okay. What are we getting here? Did I do it right? Okay, so we're going to add now the 4a on this side. So you get negative 12, because this zeroes out, zero property, equals 46a. And if you divide both sides by 12, or by 46, oh my God, you get a equals negative 12 over 46, and you can reduce that as negative 6 over 13. So my solution set is negative 6 over 13. All right, and the next one is, this one we have two distributive properties. So the first thing I'm going to do is get rid of the parentheses and distribute here. I'm going to do this one and copy everything down. So we get negative 32k minus 32 plus 6k equals, and I'm going to go ahead and leave the 2 here. If you want, what you can do, I'll go ahead and do that. It's a positive 2. I'm going to take him and move him here. Makes it a little easier. So you get negative 6k plus 6 plus 2. Now I'm going to clean up both sides. And what I'll get here is negative 32k plus 6k is going to be negative 26k. And then I'm going to copy him down. So basically I combined those two. Now, this side is a little easier, negative 6k plus 8. And now I'm going to start doing multitask. So this is what I'm going to do on the next video. I'm going to do 2 steps at once. I'm going to add 26k to both sides. And I'm going to subtract 8. So I'm saving a little time by doing that. These cancel. These cancel. My k is going to be on the right, and my constant's going to be on the left. So this is going to be 20k. So k is going to equal negative 2. And basically, I didn't even divide both sides by 20. All I did was say what number times 20 gives me 40. And that would be negative 2, because 20 times negative 2 equals negative 40. On these easy ones, start practicing trying to do these in your head. All right, so my solution set is negative 2. And the last one looks really complicated. It doesn't look too bad. I'm going to go ahead and distribute and clean this up. And you just have to combine like terms and all that good stuff. I'm going to go ahead and combine those. That's negative, you could say that's like negative 8 keys plus 6 keys is negative 2 keys. Now I'm going to clean up this side a little bit. Negative 5 keys plus 6 keys is 1 key. And then I have negative 15, or 18 minus 15 is 3. I'm going to go ahead and do 2 steps here. I'm going to add 2k to both sides. And I'm going to subtract 3 from both sides. When I do that, these cancel and these cancel. So we get 3k. And if you want, you could add a 0 here if this helps. So 0 minus 3 is negative 3. And again, try to do this in your head. What number times 3 gives you negative 3? And that's negative 1. Or you could just divide both sides by 3, and you get k equals negative 1. So my solution set is negative 1. Now in the next video, I will be doing basically the same kind of problems, but I will be going faster. And I will be doing this multi-step process like we did on the last 2 problems.